Lesson is on properties of materials. We will first look at the elastic properties of materials. What is the meaning of elasticity? Well, we are all familiar with it. If we say this is an elastic band, why do we call this an elastic band? Because it is elastic. Now, what is that particular property called elasticity? I think it is very often misunderstood by many people, the property called elasticity. Let me ask you, is this elastic band or this aluminum rod, which is more elastic? What do you think? This is aluminum. Well, this is the elastic band. Which is more elastic? Well, I need to rephrase that question to make the meaning of elasticity clearer. Which of these can withstand a greater deforming force and still keep its shape? Now, you know that if I use a greater deforming force on this elastic band, it's going to stretch beyond the limit so that it will not return to its original shape. Whereas, if you look at this ball, I can apply a large amount of deforming force on it. It still will not change its shape or its size considerably. Well, it will change momentarily, but it will regain its shape when the deforming force is removed. Why is steel used for constructing bridges? You see, bridges and great buildings are made to withstand great stresses, great deforming forces. Under the action of great deforming forces, if a structure begins to lose its shape, then the structure will collapse. And therefore, materials used for constructing bridges and tall buildings must be very elastic. Now, does it mean that they should be like this? No. It means under the action of great deforming forces, they should be able to keep their shape. They should be able to withstand the deforming force. So elasticity is the property of an object to withstand deforming forces. You must understand elasticity in that sense. Therefore, we will define elasticity like this. Elasticity is the ability of an object to regain its original shape after being deformed by an external force. Alright, steel is much more elastic than rubber because steel can withstand large amount of deforming forces but still keep its shape. Deformation is caused by a stress. What is the meaning of stress? Stress, deforming force per unit area. Force per unit area is called stress. If I can apply a certain amount of force on a certain surface, what is the force per unit area? And that is a measure of stress. So stress can be defined as force divided by area. Force per unit area. What is the unit for measuring stress? Force is measured in Newton, area in meter squared. Therefore, stress is measured in Newton per square meter. Now, a stress that produces a change in length is called a tensile stress. Well, I will talk about each of those. On the other hand, a stress that produces a change in volume is called a compressional stress. And there is one other stress, that is a stress that simply deforms the object at a certain angle is called the shear stress. So there are three types of stresses that we will be looking at. The first type of stress is tensile stress, a stress that will change the length of the object. Compressional strength, a stress that changes the volume of the object. And shear stress that will change the angle. Let me see if I can show these different stresses using a simple example. Now here I have a lead ball hung from a string. That means the weight of the lead ball is pulling the string, causing its length to change. Is that right? It's causing an elongation. So you have a tensile stress. The stress caused by the weight of this object is a tensile stress. Now let me ask you, how will I measure this stress? Stress is force per unit area. Now, what is the area on which this force is acting, the weight of this object? The area on which this force is acting is the area of cross-section of this string. For example, if this is the string which is being pulled, it is being pulled at this area. It is the area of cross-section. If the wire is circular, it's a round object, then that cross-sectional area is a circle. And therefore, if I can now pull this by suspending a weight, that weight will be acting at this cross-sectional area. Area of that circle is pi r squared. Now, watch this one, a similar example. I have a wire being stretched by a load. You can see this is this load stretches the wire, causing an increase in length. This is a tensile stress. Now, in many construction industries, tensile strength that causes increase in length or decrease in length. For example, if I keep, let me see if I can show this completely. If I keep this on the book and load it up at the top, you can see the stress is now changing its length, decreasing its length. Is that right? This is a tensile stress. So any stress that causes a change in length is a tensile stress. Now look at this stress. I have a ball that is held between the clamps here, and if I tighten the clamp, now look at this, I'm going to tighten it. What am I doing? I'm applying a force, pressing the object from either side. It is a compressional stress. Now, the third type of stress I talked about. Do you remember the third type of stress I talked about? It's called the shear stress. Shear stress. Let me see if I can show that to you. You can see I have a book here. If I apply a tangential force on the top surface, look what happens to the book. Now, what happened here? There is a change in the angle before I apply the force. Now, this is before I apply the force. Before I apply the force, the edge of the book is vertical. This angle is 90 degrees. Now what happens when I apply a shear force? The force I'm applying is tangential to the top surface. Now what happens? The edge of the book is now at an angle. So this is the effect of a shear stress. A shear stress causes deformation at an angle. If you look at this edge, wasn't that vertical before the force is applied? And now, after the force is applied, look at that edge. It now makes an angle with the vertical. So, we got three types of stress. What are they? Tensile stress, compressional stress, and shear stress. Here I have illustrated the three types of stresses. A stress that causes a tension, a stretching force, which changes the length, either increase or decrease. Well, that is a tensile stress. You have a compressional stress, and look at this, a shearing stress. The forces are parallel, and what will happen as a result of this force? As a result of this force, the object is going to look something like this a little later, like this. So you have a change in the angle, that is a shear stress. Well, now the question is, if you have a stress acting on an object, what will that stress do? A stress will produce a strain on the object. When an object is subjected to a stress, it will suffer a strain. Well, the ratio of the change in length to the original length is called the tensile strain. So when I suspend this ball from the string, the string is subjected to a stress. As a result of the stress, the length of the string will increase slightly. If you now take the ratio of that increase in length to the original length, that ratio is called the tensile strain. So if delta L is the increase in length for an original length L, then tensile strain will be delta L over L. Now tell me, what is the unit of tensile strain? Delta L is measured in meters, L is measured in meters. It has no unit. So it is a simple ratio and it has no unit. The ratio of the change in volume delta V to the original volume V is called the bulk strain. Bulk strain. You see, the compressional forces produce a bulk strain, change in volume. And in most cases, because compression causes a decrease in volume, we normally take this delta V as negative. Why delta V is negative? Because the compressional forces generally cause a decrease in volume. So look at this. Bulk strain is negative delta V divided by V. All right. Let's now talk about